So this question is most visit sector in a circular track. So you're going to have an integer n represent number of people, and then you have how many rounds as an integer array. So you're going to pass the value from 1 to 3. So 1 to 3 you'll traverse. Okay, let me draw on the picture. So 1 to 3 you traverse from 1 to 3, right? And back to 3 to 1. So 3 all the way to 1, and then 1 to 2 again. So you will know that this is this color. So this is the most integer that, I mean, the person who ran, in a marathon, right? So you want to return an array that's most visits sector and then in ascending order. So let's just break it down the idea a little bit. So you will definitely uh, have a person, so which is starting person and ending person. If a starting person less than ending person, you know like this is going to be the most visits sector, right? Uh, in the marathon. So you will return s to the n. So for example, 1 and 2, this is starting, this is ending. If the starting is less than ending, which is true, then you return 1, 2. So how about equal? Yeah, how about less than equal? It's going to be the same. If 2, less than 2, you will return 2 right here. So for example, you're starting at 2. Maybe I can use the second picture. Second example. So you have two people, 1, 2. So 2 will be the starting one, right? 2 goes into 1. 1's come back to 2. And then 2 again go to 1, and then 1 come back to 2. And then 2 again go to 1, and then 1 come back to 2. And at the end, 1, 2, 3, 4. And then this will be the what? So I'm just circling the pair, right? So this is extra 2 in the rounds. So you will return 2. This is because 2 will have to run another, uh, distance to sector 1. So that's why when example 1. So when s starting less than n, less than equal to n, then you just return the arrays starting to the n. How about when starting is greater than n? Then you will have to think about um, how we do the sorting, because we need to return array most visit in the sorting array. So when s is greater than n, we already know s is large, n is small. So for example, this is 1, this is 2, right? So we will have to return a sector in ascending order. So it's going to be 1 all the way to n, right? We're starting at 1. We're starting at 1 for sure. And then when we say 1 all the way to the n, and then another iteration we need to traverse is going to be starting all the way to n, right? So you will traverse 1 all the way to e, which is n. And then the starting will be from the starting to all the way to n, to the number of people. So this is the ascending order. So for example, n go to 10 or 11, right? So you will return 1, 1, 2, and then 9, 10, 11. So that's a trick. It's pretty difficult to think about it. So let's just using the simple solution for now. So result, and I will return result, and then I will have a start, which is going to be round 1, and it's going to be rounds at the last position. And then if star is less than equal than n, else, right? So if this is true, I would just have to traverse from star to the n, and then just add an index. Otherwise, I'm going to say from I equal to 1, I less than equal to n, I plus plus, and then result I, and then I will do the same thing from I equal to star, I less than equal to n, a plus plus, result I equal to I. So this is two scenario, right? So let me run it. Hopefully I didn't get a mistake. Cool. So time and space, space is all of n, and time, worst case, all of n, right? Your star is 1, and the n is what? Equal to n. So that's it. That's just the solution. So this is easy to visualize, and then if you want to optimize this, you can do this. So again, I will just have the result. And then I'm just using the idea for in I equal to 1 say 0. You can definitely. And then I less than equal to n, a plus plus, result at I. So if this is true, which is what? Star less than n, right? So I would just say result is not empty. If not empty, I would just return result. So in this case, this can be empty. You don't need to traverse when star is greater than n. So again, you're just using the same trick. Okay, so that would be the solution. Hopefully, I didn't make mistake. Cool. So time and space is going to be the same. All of n for the space, all of n for the time. So you can think about this scenario. So when star is less than n, less than equal to the n, you just return the distance between star to the n. When star is greater than n, then you want to do 1 to the n plus the range star to the n. So that's the solution. All right. See you later. Bye.